We are ready to go ahead and begin our tech talk on accelerate digital transformation with executable digital twin on Snowflake. Now, as you have questions on this topic, we do invite you to go ahead and unmute yourself and ask them, or you can enter them into the chat window. We're also going to take questions at the very end. Now, our presenter today is Nathan, who is located in our Austin, Texas location. Now, Nathan is a seasoned technology leader with over 30 years of experience driving innovation and transformation across Fortune 100 companies and global consulting roles. With a global operational expertise, Nathan brings deep domain and technical knowledge, not to mention a passion for delivering sustainable business value through digital strategies. All right, Nathan, the Tech Talk is now yours.
Thank you for that wonderful introduction, Misty. Greatly appreciated. Hi, everybody. As Misty mentioned, my name is Nathan. Today, we'll be talking about a innovation that I'm very excited. This is industry. When I say an industry, I'm talking about the modeling and simulation CAE industry that has been operating the same way, I would say, for the past at least 15, 20 years. We had some incremental innovations here and there, but fundamentally, we do have a lot of constraints in that industry, which really focuses on modeling and simulation. And what we are going to talk about today, this executable digital twin, is an industry first innovation, a major breakthrough, I would say. And there is a reason I'm very excited. And it is through a partnership of several key industry leaders. Siemens, of course. Siemens in particular, we are talking about the Siemens Modeling Simulation Simcenter portfolio group of Siemens, and Snowflake from the big data, cloud, AI, agnostic architecture standpoint, and the manufacturing cloud standpoint, and of course, Mendix, which is really about microservice architecture, rapid application development, and of course, PROLIM, bringing this entire ecosystem together to deliver this solution. So that I'll dive into it. Very briefly about PROLIM, just to give a good overview of PROLIM. We have been in operation for about 20 years now. In fact, we recently celebrated our 20th anniversary. We operate in 15 locations around the world: US, India, New Zealand, Australia, Turkey, and some other parts of Europe as well. Over 650 employees, over 1,700 very satisfied global customers, lots of awards, lots of certifications, security clearances. We do a lot of work with the military, the federal government. So we have been around, and our focus has been primarily on digital engineering, digital manufacturing transformation. We are a global platinum partner of Siemens, a global platinum partner of AWS, Microsoft, and Snowflake, all critical members of this ecosystem. So with that, again, a very high-level overview of the different certifications, awards, recognitions that PROLIM has been fortunate enough to receive in these past 20 years. I will not go too much into the details here. At a high level, this is what we do. I know this is a bit of an eye chart. I won't go too much into the details, but I'll walk you through what PROLIM does as a company. Collaborative product development. This is primarily product lifecycle management, product data management, visualization and collaboration, embedded software, application lifecycle management, industrial, IoT, largely focused around Siemens' portfolio of solutions in this space. Let me switch my laser pointer. So that means we're talking about Teamcenter, Polarian, Active Integration, Refx, Refinex, TeamViewer, Vertex, Siemens Visualization, Mendix. These are the products that we sell, service, support, implement, consult with customers around the world from a collaborative product development standpoint. The next big focus area for us is digital engineering. So this is basically computer-aided design, computer-aided engineering, and testing solutions. So that is NX, Solid Edge from a Siemens standpoint, Expedition, Caliber, Questa, Descent, Velos, Siemens Capital, Harness, Simcenter, Altair. Those are really the products that we focus on in this space. Increasingly, we are beginning to do a lot of work here around AI and design reuse. That has been recently the biggest ask from our customers. And some of you may be familiar with digital twin. Some of you may not. I'll explain what a digital twin is a little bit later. But when it comes to digital engineering, there are two types of twins we focus on: product digital twin and performance digital twin. This topic today is going to be largely focused around performance digital twin. And then the next big focus area for us is digital manufacturing. So that's your manufacturing operations management, manufacturing execution, quality, lab information, planning, scheduling type solutions, largely focused around Siemens Ops Center portfolio. PROLIM also has a custom off-the-shelf smart manufacturing solution called Promise. I'll give you a glimpse of that as well. But also we focus on computer-aided manufacturing, which is basically Solid Edge and NX, manufacturing process planning and simulation, which is Technomatics, industrial IoT and smart manufacturing, which is Siemens Industrial Edge, Insights Hub, and with our partners, AWS, Microsoft, and Snowflake, they also offer their own ecosystem of manufacturing cloud solutions. We do a little bit of PCB manufacturing with Valor, supply chain management, and of course, a digital twin. Here we are talking about a production digital twin. The next big focus area for us is rapid application development. I'll talk a little bit about it, but we are beginning to see a lot of momentum in the marketplace as customers are focusing on enterprise digital strategy. How do I get rid of my legacy application technical debt? How do I accelerate? How do I create a containerized microservices architecture? Rapid application development is really the critical enabler for that. And we focus on Mendix low-code platform, but we have over 200 plus solutions that we have developed and deployed in the marketplace, including many SaaS solutions that we are supporting currently. And of course, we do professional services. That's your traditional consulting, strategic staffing, IT services, program management, and change management and training type services. We do a lot of knowledge management and training support for our customers globally. In fact, we are a Siemens certified trainer. We train customers on many things Siemens. An area that is rapidly emerging and rapidly growing for us is this: cloud, AI, data, and security. A lot of customers are demanding solutions in this space. Many of them have started the transformation to these areas. When you're talking about big data, data warehouse, data migration, we are a partner of Snowflake. We also have our own migration solution called Diaspora. AI is big focus area for us, especially industrial AI. And when we say industrial AI, we are talking about Rapid Miner, Siemens AI, Mendix, Maya, things of that nature, but also traditional AI from industry, from an automation standpoint and agentic technology standpoint. A lot of work around managed cloud services. As I mentioned, we have strong partnerships with AWS, Azure, and Snowflake. And we do public, virtual, private, hybrid, lift and shift, all kinds of cloud services. Increasingly, we are also beginning to do SaaS support. Siemens itself is moving their entire product portfolio to the cloud. Big one is Teamcenter X, but there is also Ops Center X, many other X's coming from Siemens. And we will be supporting most of those. And we also have our own SaaS solutions through Fascia digital platform that we support. We also do a lot of work for customers around HPC, high performance compute. This is again modeling and simulation. This is where the performance digital twin also comes into play. That is typically a very compute intensive operation. And we provide services around cloud enablement for our customers to manage that capacity. And again, when you're talking about digital twin in this space, we are talking about an executable digital twin. I'll again go into the details of what I mean by that a little bit later. Okay. So I'll spend a little bit of time talking about the manufacturing data cloud, in particular, why we are working with Snowflake and why we are using Mendix to enable this solution. Yeah. So when we say manufacturing data cloud, most of our customers tend to be either in the discrete or process manufacturing space. And what you're seeing here, this animation, is actually coming to us from Snowflake. Snowflake has a cloud enablement for their manufacturing customers. And this is a real-time visual view, almost like a neural network view globally of the collaboration between Snowflake customers. Because once you start creating big data on the cloud, now we're talking about how do I create an ecosystem around this data. Specific to Snowflake, that means pretty much every single Fortune 500 manufacturing company that you're thinking about has something going on with Snowflake and have their data on Snowflake, collaborating with their suppliers, with their partners, and with their customers as well. And then, of course, when you have this kind of an ecosystem, mining this data and looking at global supply chain risk patterns, risk analysis, logistics planning and scheduling, impact of act of God events like earthquake or tsunami, right? Supply chain has to be very dynamic. Now we can start thinking about how do we enable all these additional capabilities. That's really the power of this ecosystem. And when we talk about the Snowflake Data Cloud, we are talking about AI, ML, we're talking about applications, we are talking about cybersecurity, we're talking about data engineering, data warehouse, data lake, a unified store, a marketplace where you can start, whether it's for internal consumption or external consumption, you can actually start publishing your applications in the marketplace and well-governed collaboration. And again, the key with Snowflake, why we chose to partner with Snowflake, it is a cloud agnostic platform. What do I mean by that? Most of my customers, depending on the region, location, country they operate, they're using one of the big hyperscalers, either AWS or Microsoft or GCP. If you go further east, there are many other additional players like Alibaba and whatnot. So the cloud ecosystem is a heterogeneous ecosystem. Even within the same customer, they tend to use multiple clouds. And traditionally, if you're doing cloud apps, each vendor has their own set of architecture security guidelines that you have to comply with. But if you launch your applications on Snowflake, it by default becomes cloud agnostic and it will work on every single cloud platform out there. And it will collaborate, in fact, between multiple clouds. So that's the power of that platform. And the second thing, it is also AI agnostic. What do I mean by that? Snowflake supports every single major AI LLM vendor out there, including DeepSeek from China. So if you are building an application and if you want to infuse AI agentic capability into your application, you are really not limited. Whatever your customer wants, you can build a chatbot, you can build agent technology, you can build deep mining technology, regardless of what AI native algorithm you want to use. And the third thing is it is one of the best platforms when it comes to data compression. Over 60-70% data compression happens out of the box when you start moving your data into Snowflake. And these are all very, very critical for what we are going to talk about here, which is the executable digital twin. And why? Because A, it is a very data hungry framework, because computer aided engineering, modeling, and simulation, we are talking about huge volumes of data depending on how much simulation you want to do. So there is a high storage capacity need. And it is also very compute intensive because modeling and simulation, CAE analytics, is one of the most high compute operations you can do within a manufacturing environment. So both you need high storage needs, you need high compute needs, hence high performance computing framework is required. And with Snowflake, that kind of comes out of the box in a very, very cost effective pay-per-use model. So that's why it makes a lot of sense to partner with Snowflake in this, not to mention their manufacturing cloud, which is a big one for Snowflake. Okay, hang on a second. Okay. So when we say Snowflake Manufacturing Cloud, this is what we are talking about. Your data is sitting in the cloud, of course, your ecosystem of partners, providers, shipping, logistics, contractors, customers, a lot of their data is also sitting in the cloud. Now you can start thinking, how do I do my industry specific transactions? How do I do my industry specific operations now that I have the power of this cloud, and start building ecosystems of services around it, right? And there are many that have already done it. So all the big names that you're seeing here are already part of this Snowflake manufacturing data cloud ecosystem. And PROLIM is right now in the process of becoming a key service provider in this ecosystem as well. One of the solutions that we will be launching in this ecosystem is called PROMIS. PROMIS stands for PROLIM Manufacturing Intelligence System. It's a smart manufacturing solution that PROLIM has developed, and now it has been launched on Snowflake. And we will also, of course, be focusing on this executable digital twin solution on Snowflake in terms of the value that we bring into this marketplace. I'll talk a little bit briefly about why we are using Mendix, because those are really the two critical enablers for this solution, in addition to the Siemens Simcenter framework, which is the Siemens modeling and simulation solution. If you look at enterprise evolution over the last 20, 25 years, back in the 2000s, we had these big monolithic systems, big ERP, big PLM, big MES, CRM, supply chain, security systems, and they were loosely connected. They were all deployed on-prem. That used to be the architecture. In fact, quite a few customers of ours are still in this architecture, trying to figure out how to enable a digital transformation strategy for them. There's a good framework, but it is not an agile framework. It is not easy to drive change. It is not easy to respond to changing industry needs if your IT technical architecture looks like this, right? So in the 2010s, we started moving to the cloud, right? And we started doing a lot more tighter integrations. We started discussing enterprise integration architecture. We started developing integration standards for how PLM should connect with ERP, how ERP should connect with MES, and so on and so forth. Some of these, not all, but some of these were also now available on the cloud. So we had this hybrid architecture. And in the 2020s, we now pretty much have moved to this hybrid cloud edge cloud architecture. What do I mean by that? Uh, Back in the 2010s, if I went to a CIO and said, hey, let me do your HR on the cloud, they would kick me out. But now HR on the cloud is the norm. Nobody blinks an eye about sensitive HR data sitting on the cloud. So the mindset has changed. The cloud architecture has changed. Customers now trust cloud a lot more. It is scalable, it is efficient, it is cost effective. And so now we are looking at how do I create a true public cloud architecture, maybe a virtual private cloud architecture, or a hybrid cloud. And increasingly, we also are talking about edge architecture. When we say edge, typically we are talking about something that is sitting in the four walls of a plant, contained within the plant, but still a cloud native architecture localized within a plant. So we are beginning to see all of these evolutions happening. As you can see, the picture keeps getting, the boxes keep getting smaller and smaller, and this is by design. What is happening is now, as this shift is happening, we are beginning to see what we now call as microservices. That means instead of big monolithic enterprise applications, we are now beginning to deploy more and more functional modules, smaller scale modules that can talk to each other. This is the microservices architecture, and this is what cloud architecture these days looks like. Every cloud native application today largely relies on a microservice containerized reusable cloud architecture. That gives a lot of flexibility. You can change things very quickly. You can respond to market demands very quickly. This is really how the industry is evolving. And this architecture demands a different mindset, right? It demands a DevOps. It demands a continuous CI/CD type mindset within the company. That means there is no downtime. You cannot stop your application to upgrade it. It is always running. You got to be able to continuously integrate and continuously deploy and support it. This is the architecture that we're talking about. And so this is where Mendix fits in. Mendix is part of Siemens now, and Mendix is a low-code platform, meaning I can develop applications very, very quickly, and it will handle the architecture that I talked to you about before out of the box. It is an enterprise-grade platform. It is not a smaller scale low-code app that maybe companies are familiar with currently. I won't mention the names, but there are many other low-code platforms that you can maybe use to do a process automation or a small scale deployment. But when you're talking about enterprise grade solutions, there is really no better option than Mendix. In fact, it has been the Gartner leader for almost 7, 8 years running. So very, very powerful and strong integration capabilities, strong AI capabilities, intelligent automation capabilities, data integration capabilities. It is a true enterprise scale platform. And when I say it is enterprise grade connectivity, this is what I'm talking about. Mendix, of course, being part of the Siemens ecosystem, it connects natively with all things that Siemens offers, right? Whether it's a Teamcenter or a 3D viewer or a CAD integration or an industrial edge connection or a ALM connector, a Simcenter integration, which is what we are using for this project. Executable Digital Twin is using this Simcenter integration. But as you can see, it connects with enterprise grade industrial solutions, and it has pre-built connectors for storages, for databases, for applications, for security, for machine learning, compute, IoT, many other things. It is native to AWS, but it also works on GCP. It also works on Microsoft. But if you are buying anything Mendix SaaS, you are basically buying it through AWS or through Mendix, but you can also deploy it on pretty much any other cloud environment as well. And it also has pre-built integrations with some of the big vendors or the big protocols you can think of. For example, MQTT for IoT, for Google, for SAP, for Salesforce. So there are lots of pre-built value. And of course, what you see here in the end is Snowflake. So Mendix works natively with Snowflake. In fact, Snowflake and Mendix now have a very strategic partnership, right? So where does PROLIM fit in? We have been working with Mendix for several years now. We probably have one of the largest Mendix service capabilities of any service provider in the world. We have developed over 200 plus Mendix solutions that have been launched for our customers. We have our own platform called Digital Fascia, which is our Mendix go-to-market platform. We provide many solution accelerators through this platform. And of course, as I mentioned, specific to digital manufacturing, we have a solution called Promise, which is our low-code, no-code AI framework that really focuses on smart manufacturing. I'll give a quick glimpse of maybe how Promise works so that you can understand our competency there. And then we will dive into the smart manufacturing.
Welcome to the Production Management Application, a smart, centralized system that brings automation, structure, and real-time visibility to your manufacturing operations. Let's start with the skill matrix. Here, you can view all operators, their JD numbers, certifications, and the skills they're proficient in. Assigning a new skill is easy. Select the skill, choose the level, and attach certificates if needed. It's a simple way to keep your workforce competency records organized and up to date. Next up is project planning. This module shows all live projects. To create a new one, just enter the project name, total units to be manufactured, the duration, and start date. The project manager can set monthly productivity targets and select the bogey type, for example, trailer or SLR bogey. Once submitted, the project goes live. From there, capacity planning kicks in automatically. It schedules when and where each bogey will be built, down to the shift level. You get full visibility into production timelines, shift by shift, day by day. Now on to workforce planning. All operators are listed on the left. You can assign or change shifts using a drag and drop interface. Color coding helps you see who's working which shift, and you can include Saturdays with a simple toggle. Finally, let's look at the production schedule. Inside each project, you'll see a full list of tasks per bogey. Each task shows the assigned operator, process details, task status, and assembly line reference, keeping the entire build process traceable and organized. Together, these modules form one connected system, aligning people, projects, and production in real time. That's the production management application, efficient, transparent, and built for modern manufacturing.
So that hopefully gives you a bit of a glimpse of promise. And again, I showed you just a glimpse of it. It is a complete framework for your entire manufacturing, operations management, and manufacturing execution management. It connects with your edge devices. It can connect with your IoT. And now it is available on Snowflake as well. So a very, very powerful platform. If you want to talk about that, we can certainly have a follow-up discussion. Now, what is the joint value proposition between Mendix and Snowflake, right? This is kind of where it all comes together. As I mentioned, Mendix talks about enterprise application development. Snowflake primarily focuses on data, big data, and Snowflake is connected with the ecosystem of major players like AWS, like SAP, like Salesforce, like Siemens. So that's kind of the Snowflake ecosystem we talked about. And Mendix and Snowflake joint have very powerful AI capabilities. Snowflake in particular has something called Cortex AI, which I will show you briefly how it works beautifully out of the box once you point it to the right data sets, and how it drives very meaningful value realization within seconds, quite literally. You're not really doing anything to make it ingest data. It is learning on the fly. As long as the data is native in Snowflake, it works fantastic. And so PROLIM, what is the PROLIM value add? Why are we working with this ecosystem? We are a premium Siemens partner, as I mentioned. We do all things Siemens, especially for this particular use case, performance digital twin. We have a very strong Simcenter practice, right? That means we do a lot of things with the Simcenter portfolio, especially Star CCM. And also now we have a partnership with Altair, the other big CAE capability provider that Siemens recently acquired. And Altair also brings rapid miner AI into this mix. So that's very exciting. And of course, Snowflake, we are a digital engineering global partner of Snowflake. So when it comes to digital engineering solutions, we pretty much have an exclusive partnership with Snowflake in that space. And now we are working jointly, as I mentioned, to become part of that manufacturing cloud ecosystem to start delivering advanced engineering and manufacturing solutions. And it doesn't get more advanced than this particular use case, the executable digital twin. Probably one of the most complex digital twins you can think of. So I probably owe you a little bit of a briefer on what a digital twin is before we jump into the executable digital twin and the performance digital twin use case that we will be talking about today, right? So what is a digital twin? Some of you may have heard it, some of you may not. But basically, a digital twin connects the virtual to the real, right? That is the fundamental reason a digital twin came into play. That means it is converting IT, IoT, industrial IoT data into insights, whether it's an engineering insight or a manufacturing insight, that depends on the use case. But it really converts real world data into insights through simulation. There's a lot of simulation involved. Increasingly, AI-driven simulation is happening at scale when you're talking about digital twin, right? And the goal is to understand the physical asset, right? Because the physical asset is already deployed, it has already been sold, it is being consumed by the customer. And your goal is to make sure that you optimize the performance of the physical asset. And that is the reason you're doing all the simulation. So the more expensive the physical asset is, the more stronger the case for digital twin becomes. For example, aerospace and defense, energy sector, plants with very high cost equipment, right? You don't want these things to go down. You want these things to be running 24/7 at maximum capacity. And a digital twin is a fantastic way to get real-time intelligence and manage those assets very, very much better than you traditionally do, right? How does this work? A lot of machine learning, a lot of empirical modeling, a lot of simulation modeling goes into enabling the digital twin strategy. And of course, Siemens is one of the industry leader, I would say, right now when it comes to digital twin technology across its portfolio. Now, specific to this particular solution, we are doing this on the Snowflake data cloud. But of course, we are consuming modeling data coming from Siemens ecosystem. I'll show you what that is. And of course, we are working with multiple cloud vendors because Snowflake itself is cloud agnostic. And of course, there is also the possibility of a on-prem edge architecture for this solution as well. Okay. So what are the different types of digital twins out there, right? So this is probably important to know because we'll be focusing on one of these types today. But there are many different types of digital twins. But the foundation is a smart physical asset, right? When I say a smart physical asset, it needs to be self-aware to a certain extent. What do we mean by that? It needs to have some basic capabilities. It needs to have some IoT component to it, Internet of Things. What does that mean? If you have IoT enabled asset, then it is capable of communicating in real time using the internet. That is the foundation of IoT, right? So it doesn't matter whether I have a refrigerator in my home or a washer or a dryer. These things all now come with IoT, right? They're all becoming smart refrigerators, smart appliances. That means they have sensors in the device. The sensor is measuring many different things, and it's monitoring the device performance in real time, collecting all that information. And then using IoT, it can send and receive information back and forth, either with the customer, with the manufacturer, with maybe a service provider ecosystem. But fundamentally, that's what we mean by a smart physical asset. And smart assets have become a game changer, especially in the consumer appliance world. Certainly in the automotive industry, now we are seeing connected cars, but also in many other industries, aerospace and defense, even in the process industries as well. This is a game changer. So the first type of digital twin we had was called a physical digital twin, which is basically a 3D accurate representation of the physical asset. So in other words, if you had a fully defined geometrical model, then at least you have the beginnings of a physical digital twin. And if you had any CAE modeling to go with it, your physical twin got even more smarter, right? But this is kind of how the digital twin industry got started maybe 10, 15 years back, first with a physical digital twin. And then we started looking at a production digital twin. So when we say a production digital twin, now we are talking about a manufacturing operations environment. So typically we're talking about a plant where you have some asset sitting in the plant, or maybe you are talking about the energy grid where you have a big asset sitting, or an oil rig where you have a huge asset sitting in the middle of the ocean, right? So very capital intensive assets. They probably have a lot of MES capabilities, a lot of PLCs, a lot of IoT built into that framework. And now we are talking about creating a digital twin for that asset. And then we can start doing things like smart manufacturing, predictive maintenance, predictive quality, managing uptime, managing performance, lots and lots of possibilities after that. The goal is to keep the asset operating at peak capacity. Now we are beginning to see a lot of product digital twins. As I mentioned, I gave you some examples from the consumer appliance world, like a smart refrigerator that can notify you when you are running out of milk. This is reality today, right? Or a smart HVAC system that will tell you, hey, it's time to change your filter, or it's time to do this service, right? So they are all now capable of self-monitoring, self-diagnosing, and communicating with a ecosystem. Big focus area has been in automotive for the past several years with the connected cars. That is a big high impact game changer when it comes to product digital twin. Connected cars, it's still I would say, going back and forth in terms of the level of maturity. There are 5 different layers of maturity with connected cars and autonomy and driving. That industry has been going a little bit back and forth, but that's a major game changer. It is also a reality today in drone technology, in aerospace and defense. A product digital twin is a must in those worlds. Performance digital twin, this is what we are focusing on today. A performance digital twin is really not looking at a physical asset. It is looking at the analytical model that was used to create the modeling and simulation analytics for the physical asset. In other words, a performance digital twin is looking at a CAE model associated with a physical asset, right? That is a fundamental difference. CAE models are important because without that, you really cannot diagnose your product. You really cannot see how well it is going to perform in the real world. That's where we use CAE to validate a lot of engineering constraints, design constraints, manufacturing constraints, performance constraints. And so today we'll be focusing on that particular digital twin. And last but not least, executable digital twin. Typically a reduced order magnitude, doesn't need to be, but typically a reduced order magnitude version of one of these other twins. It could be a performance twin, it could be a product twin, it could be a production twin, but it is a raw version of it, so that we are focusing on some very targeted use cases, but converting it into an executable version, just like any other executable file. The moment it becomes executable, it is not constrained to one platform or one environment. Now, all of a sudden, you have the power to run the digital twin anywhere. In our case, we are running it on Snowflake, not just within the Siemens ecosystem. Now it's out of the Siemens ecosystem. It is running on the cloud. It is running on Snowflake, and we can bring the scale of the Snowflake platform to this digital twin. That is the power of a XDT, or executable digital twin. I know that's a lot to throw at. Any questions on this before I go further? I'll take that as a no and continue. So what are we doing? This particular use case, I'll dive a little bit deeper into it. So executable digital twin, the one that we are doing here, you can see a high-level overview of this architecture. You can see this mixture in the middle. That is the use case we are simulating. So this is a use case for a process industry, not a discrete. So this is an industry that does chemicals manufacturing. And a key part of that manufacturing process is this industrial grade mixer that is used to actually derive the product. And it is a very high intensity device, large scale device. So there is only so much you can do physically. When I say physically, in terms of putting physical sensors into the device to measure, diagnose, very difficult because of the high RPM speed of the device. They will get crushed. So we have to now rely on modeling, simulation, analytics, maybe even AI, to start diagnosing this process and see how we can optimize this process. So that's kind of where this entire use case came. One of the complex use cases when it comes to CAE and simulation modeling, because of the nature of the process itself. Right, so we chose to use this use case to prove the executable digital twin possibility because of the complexity involved with this particular use case. The idea being, hey, if it works for this use case, this should work for pretty much any other discrete manufacturing use case, right? And so how do we do it? First, of course, you have a simulation model. When I say simulation model, now we're talking about Siemens Simcenter. And in particular, Star CCM is the simulation tool that we used for this to develop the simulation model for this entire simulation process. And then we create the digital twin. This is the traditional digital twin. That means you're developing this within Teamcenter. Teamcenter supports one of those product digital twin that we talked about. In this case, we are creating a performance digital twin right here. And then we are now building a Mendix application to run this digital twin on Snowflake. So this is where the ecosystem comes in. Now, I'm taking my performance digital twin that I built here, and then using Mendix, I'm creating a user interactive layer. So you can actually now start engaging with your digital twin like you would work with any other application. And now we are creating an executable digital twin or executable version of that performance digital twin. And now I'm loading that on Snowflake's Snowpark ecosystem. And then once it gets there, now I can do a lot of things because it has infinite compute capacity. It has infinite storage capacity. So all of a sudden, I don't have any compute limitation. I don't have any storage limitation. I don't need a dedicated high performance cluster to run my CAE model. I don't need expensive software. I don't need users that have a PhD degree in modeling and simulation. The average user with the power of AI can actually start interacting with the digital twin. This is what I mean when I said we believe this could be a game changer to the CAE industry, because the industry has been constrained for many years with high cost, very limited compute capacity environments because of the HPC, and also high complexity of the system of the solution itself. It is very complex to interact with CAE software, and very specialized skills have been historically needed. You still need it, but not at scale. Right? You still need to create the model. So you do need experts, but you don't need experts to run the simulation itself anymore. You can use this framework and really democratize your CAE data. That is the power of this particular solution. And how we do it? Of course, we start with CAD, starting with the CAD in the Teamcenter, and then we are doing the visualization using Star CCM, and then we are creating the AI model out of that visualization, and then we are creating an executable digital twin that has this AI integrated into it. And then last but not least, we are now running it on Snowflake. And then we are able to do all kinds of performance analytics with this executable digital twin. And again, to talk about the complexity of this use case, this is what we are dealing with. So there is Teamcenter, there is Design Center, there is Simcenter, there is Snowflake, there is Mendix, there is AWS. A complex ecosystem for sure, and that's where PROLIM excels, because we understand this vertical stack completely, and we are able to make this integration work and work beautifully. Right. I got to give credit to my team. We had a fantastic team of key leaders within PROLIM and them and their bigger team. There are a lot of people that worked on enabling this. But Padma Kumar, who heads our Simcenter practice, Santosh Kumar, who heads our Snowflake practice, Divya, who heads our cloud, Harshak, who heads our PLM Cloud Solution Architecture Group, and then Hanumesh and Rahul from the Mendix team. And I have not even listed the broader Siemens partners that we are working with and the broader Snowflake partners we are working with. But we have the highest level sponsorship and support from both Siemens and Snowflake to enable this solution. Otherwise, this would not have happened. So what does it look like? I'm actually going to run this. Hopefully the sound comes across okay.
Start by loading the base simulation, which represents the mixer model configured with a single set of operating parameters. Set up the mesh, assign the appropriate boundary conditions, apply the multi-phase physics models, and run the simulation. Once the solution is complete, right-click the simulation node and select Create Design Manager Project to initiate a parametric design exploration. Define your design space by specifying multiple sets of input parameters, such as impeller speed, RPM, particle mass flow rate and volume fraction of water, and initiate run study. After completion, export the results as an FMU or a Java file. Here we are deploying an executable digital twin, built with Mendix, using Snowpark Container Services. First, we set up a service within Snowpark Container Services. This fully managed platform lets us deploy and manage our digital twin application efficiently, without worrying about infrastructure or security. Next, we log into our Executable Digital Twin, or XDT, developed in Mendix. For this demonstration, we're simulating a mixer operation. Inside the XDT application, we have full control over key mixer parameters, particle weight, rotating time, and water level. By adjusting these, we can influence the mixer's behavior in real time. Once we run a simulation, the XDT instantly generates valuable virtual sensor data such as torque, particle uniformity, mixer's temperature, power consumption, and impeller max displacement. All these results are seamlessly pushed into Snowflake, where they're securely stored in a dedicated, ready for further analysis and reporting. With this integrated solution, you can easily deploy, control, and analyze your digital twin simulations, unlocking new possibilities for process optimization. We're taking our executable digital twin analytics to the next level with Snowflake Cortex AI. After running our mixer simulation, all the operational data, like motor temperature, power consumption, rotating speed, and torque, flows directly into Snowflake. Now, let's see how Cortex AI turns this raw data into actionable insights. First, we'll analyze the relationship between average motor temperature and power consumption. Using Cortex AI's powerful built-in models, we can quickly visualize trends and correlations. For example, as the motor temperature rises, we might notice a corresponding increase in power consumption, helping us identify potential inefficiencies or early signs of equipment stress. Next, we'll examine the link between rotating speed and torque. Cortex AI enables us to plot these variables and uncover how changes in speed impact the torque required by the mixer. This insight is crucial for optimizing performance and preventing mechanical overload. What makes Cortex AI especially effective is its ability to handle these analyses natively within the Snowflake platform. There's no need to move data between systems or rely on separate tools. Everything happens securely and efficiently in one place. This unified approach not only streamlines our workflow but also ensures that our insights are always based on the most current data. Beyond these examples, Snowflake Cortex AI supports a wide range of analyses. Whether you want to explore the impact of water level on mixer temperature, study particle uniformity, Cortex AI makes it possible using conversational natural language AI processing. By integrating AI-driven analytics directly into our digital twin environment, we're unlocking deeper insights, improving operational efficiency, and making smarter, data-driven decisions, faster than ever before.
So hopefully that gives you a overview or a glimpse into this entire solution. I cannot say how excited I am as the CTO. This is the kind of technology that could be truly game-changing, could be truly disruptive in the marketplace. An area, a very high complex area in the product development domain, which is modeling and simulation, and a very, very high complex use case, especially the mixture use case that we selected from the process industry. And you see the power of the platform and the power of AI in being able to analyze and help customers derive meaningful operational insight, right? That is the bottom line. And cannot wait to see how the industry responds to this and to help customers with this particular solution. So wrapping up, customer value, right? So in this particular case, we're talking about Simcenter, we are talking about Mendix, we are talking about Snowflake from a performance and digital twin standpoint. And you saw the power of the platform, you saw the power of the end-to-end digital twin lifecycle go into action. And you also saw the power of the innovation, makes it really seamless. Conversational AI is the norm these days, and you can ask simple queries and expect answers to complex problems. That is what is happening with conversational LLM AI and NLP AI these days. And you saw how Cortex AI does it natively within Snowflake. Of course, you can bring in other AIs into the mix if you want. You can bring in traditional AI ML as well. And we certainly are planning to expand this with more capabilities, maybe with the RapidMiner AI coming into the mix and RapidMiner now becoming part of Siemens and supporting Snowflake as well. So we look forward to how we can leverage those capabilities moving forward as well. But the key here is the ability to integrate physical and virtual sensor data. So physical sensor data, depending on what you're trying to measure, there's only so much you can do physically. with implementing sensors. And when physical sensor is not a possibility, now with the digital twin approach, you have the potential to create virtual sensor data, which we did a lot in this particular use case. Second one is, in terms of license cost. We sell Siemens, and we know the cost of Simcenter. It is expensive. Simcenter is an expensive platform. Even Siemens recognizes that. And to federate, to democratize the CAE data, that has been a constraint. So that is the reason Siemens is also working on this executable digital twin with us to see how we can really democratize this and make it more mainstream and more permeable in our customer landscape, right? So you saw that once it comes into Snowflake, all of a sudden you have a very low cost pay-per-use landscape with very high compute, very high storage, very powerful native embedded AI capability that you can leverage, which in the traditional landscape, you would have to stand up multiple HPC clusters to do in the traditional CAE and invest in multiple licenses for Star CCM or Simcenter to do something like that, right? And of course, the HPC, we talked about that, high performance compute clusters. You still will need it on the CAE side, but on the analytics side, once it comes into Snowflake, there really is no need for that because Snowflake brings that unlimited compute capacity to the table and unlimited storage capacity to the table. And last but not least, it doesn't matter what your cloud architecture is, right? You could be on AWS, you could be on Azure, you could be on GCP, or you could have a mix of all of this. With this architecture, we will support all of your cloud constraints. It doesn't matter what your cloud architecture looks like. We can support it because of Snowflake's cloud independent architecture. So where are we going from here? We are offering hackathons, XDT hackathons. Please reach out to us for more information on this. But fundamentally, how it works is we will talk to you. We will understand your existing challenge, existing use case or use cases as it relates to digital twin. That will happen through a discovery session, a quick, half a day session maybe. We'll focus on the key use case, key data points that you currently have. And then hopefully within a very short time frame, bringing in this framework that we talked about, give you a use case that actually demonstrates how XDT approach can help you. And then after that, you'll be able to make some meaningful decisions in terms of how you want to evolve or develop your digital twin journey. So that's the offer on the table. And of course, why PROLIM? I don't want to keep repeating it, but as you see, we have very deep domain expertise when it comes to digital product development, digital engineering, digital manufacturing, enterprise IT, cloud ecosystem, and modeling and simulation in particular. That's the value that we bring to the table. And as we have demonstrated here, we have the competency to deliver very complex solutions to the marketplace. That's what we have been doing for 20 years. So with that, it's a wrap for me. Thank you all for your time and attention today. And I look forward to conversing with you, collaborating with you soon.